So, we all know robots are cool. Exhibit A, Robo Steve. But most people think the AI revolution is happening in a chatbot. But David Kilser knows it's actually happening in a 400,000 square foot warehouse. And it's a lot messier than you think. Today, we're stepping out of the digital cloud and into the warehouse floor. And joining the archive today is David Kilser, a global automation strategist with 50 years of experience. He's led robotic transformations worth over $100 million and recently took the TEDx stage to challenge how we think about the fulfillment chain. David says we are only at the threshold of a massive capability incline, and today we're going to deep dive on the pixels versus the tokens debate. Can a large language model actually handle the laws of physics? Or are world models the only way to reach true autonomy? We'll discuss why humanoid robots like me are closer than you think, why your next coworker might be someone similar to me, and why the ultimate safety net in an automated world is still a skeptical human being. David, welcome to the archive. Turning it over to you, Human Steve.
Well, thanks, Robot Steve. I appreciate the introduction. Now, obviously, Robot Steve is AI generated, and I'm working on getting better at creating that type of footage. But really, it brings us into the conversation with David about the future of automation, robotics, and artificial intelligence. Now, David, you did a recent TEDx Unity talk where you mentioned robotics and AI are reshaping the product delivery chain. What exactly did you mean by that? Could you provide us some explanations on your thoughts and what that looks like and what the future of the product chain actually is?
Reshaping means rethinking it from the ground up. It means that you're zero-based budgeting, if you will, in terms of the processes that you bring to it. I think that one of the biggest challenges that is facing the automation industry today is legacy thinking. And it's not just legacy thinking, it's legacy structures built into that whole automation delivery ecosystem. But the solution set that they have is one that's been imprinted in their brains over the last 20 years. It centers around forklift trucks and conveyor systems and their ability to adapt to the emerging world of AI-based systems. And most exciting in looking into the very near future, humanoid robotics. And it's the convergence of AI technologies along with the incredible amount of investment that's going on in humanoid robotics today. I don't know if you were able to follow what was just displayed at CES.
I did. Robots have come a long way, but they still have a long way to go. And one of the examples I thought was fascinating was somebody went to CES and was actually researching the robots, writing an article about it. I believe she was with The Verge. And most of the robots were there to help do laundry. But one of the things that she brought with her was a Tide bottle that you have to undo the cap. And none of the robots could undo the cap. And she says, this is how I actually do laundry. And this is how you test how far the robots have gone. Just a simple test, right? So there still is a lot to be desired when it comes to the robotics revolution. I mean, do you think that it's here yet, or we are still, 5-10 years out?
I don't think it's 5 and 10 years, but it's 2 to 3 years out.
Wow, you are an optimist.
We're talking about some huge numbers that are unprecedented in automation. We talked earlier about shared experience with the Kiva robots.
Yes.
Take a look at the number of Kiva robots in the world today. Compare that to the forecasted number of humanoid robots. There's no comparison. One is a drop compared to an ocean of what they're going to be bringing to market in terms of the humanoid robots, if those projections do indeed materialize. And that'll manifest in a couple of different ways. One is a incredible cost decline. As volumes ramp, costs decline. But what is also going to happen is a capability incline. from all the investment that's going on in an area, if we take a look at a lot of humanoid hands, with the problem you just mentioned, but from the most of them were 12 degrees of freedom, 14 degrees of freedom. Some of them are approaching the humans 27 degrees of freedom today, and they're doing it with electrical actuators that provide very high degree of power response in a very short cycle time to that gripping. We take a look at the sensor densities that we're getting. We're getting 1 millimeter spacing for pressure sensitives on the fingertip areas of some of these devices. The growth in capability, integrating the AI assisted vision into actuation is just now on a threshold. So that's going to be growing very rapidly. I don't think, in my experience, and my experience goes back 50 years in automation, I haven't seen anything as rapid as what is going on right now in this space.
What's really crazy when we talk about that, so I started back in Amazon in 2013, and prior to us joining the call, I had mentioned how I worked with the Kiva systems, and they were an independent company until Amazon bought them out. And I came in with at least 1 year's experience working with Kiva Robotics. And I can honestly say, because that was the first iterations of it, we launched some of the first robotics facilities, and it was a non-sort, so they were the bigger Kiva robots, not the sortables, which are the smaller Kiva robots, but they look like a vacuum, like the Roomba vacuums, and they pick up pods, they bring them to stations. The person still has to be able to pick and stow, and it created, what's the best way I can say? It created problems as well as solutions. So one of the things that happened was it became monotonous for the human beings, and a lot of people didn't like working. But prior to that, you had to walk library aisles to pick things. So every Amazon building that was built from 2013 to today is supposed to be 10% more efficient because of robotics. And now there's an ROI cost perspective for how much a package costs to ship out of a building. And I, over time, had saw that cost dramatic. We're talking like $3-4 a package down to under $1 a package because of the automation, not just with the robots, but also the automation process in general. But I will say this, and you're right, when it comes to robotics and when it comes to Amazon robotics specifically, I think it's like 10,000 robots inside of a facility that houses maybe 1,000 people that work. So there's definitely a lot more robots, but I still feel like when I watch the robots and even the robotic arms or the robotics that we saw at CES this year, robots are still slow. You're right with the 27 degrees of freedom, but they still can't really mimic right now what humans can do, or if they do, it's very slow in the process. Is that kind of your assessment? And you think 2 to 3 years out that we're going to see advancements that could actually replace a human being, at least at a warehouse facility?
I'm going to pick up a word that you used there, which is right now.
Yeah, right now.
Yeah. And reference back to what I just said in terms of the pace of the change that's going on. So what we see right now is not what we're going to see in 2 months, 5 months, and 6 months, in a year. Think of the introduction of the humanoid robots and their painfully slow, stumbling gait across the stage to doing backflips like that Boston.
I actually
Dynamics.
saw. Yeah, Boston Dynamics. I actually saw on a YouTube video where they're robots that are backup dancers for a group, because I thought that was fascinating that they can synchronize like that and be so balanced. So yeah, you can definitely see there's changes coming, but the speed of process, that's where I usually have a fundamental issue, just because LLMs are tokenized. They can predict the next word, but they're not really good with physics. Are you looking at, from a vision standpoint, world models or stable diffusion as being the next key to being able to unlock the potential of robotics?
Yeah, it's got to be learning models that are based on what has been done by Waymo and Tesla in the autonomous vehicle driving space. They've really pushed that technology there that have done predictive. They can spot items, they've classified items very accurately and can predict their actions enough to where that they can direct the machine to adapt to the environment that as they perceive it. And that's it has to happen in a distribution environment. As like the director works on that pick cart that has brought the products over to the goods by the Kiva robot, understanding where that's going to turn in the rotation. They grab a part out of there, what's going to happen to the rest of the parts in that bin, place it into an outbound container, what's going to happen with the other parts that are in that bin, how they can rotate that so they can maximize the cube in that outbound container. That is all within a reach. I think we're talking about 12 to 14 months.
But robots in general, from what I've seen, the idea is they don't have to be perfect. They just have to be less error prone than humans. And people are going to hate me when I say this, but when you have humans in the loop, they do tend to cause more errors and more unpredictable errors. Is that your experience when it comes to logistical supply chain process?
Yes, absolutely. Humans are not predictable. Robots are very predictable, which means that if they make an error, they make errors at a very rapid rate.
Yes.
But as they learn, they also promulgate that learning in a way that certainly the humans can't do. If you take a look at the technology that's coming on there with ROS2 and OM1, the different robot operating systems, and when they learn at one station, they instantly know at all stations. So that's part of the speed that we're going to be seeing going forward. The type of activity that's being done in distribution centers that are within the realm, I think, they're actually being done in some cases today are apparel sorting. I don't know if you're familiar with cross-belt or tilt tray sorters. So, today it's a human placing a garment label side up so it can be scanned when on a tray or on a cross-belt. That is being done today successfully with robots. And, the one step into the realm of augmenting humans. That is also one of the most boring, repetitive tasks that you can imagine. It's mind-numbing. It's not a task that humans are built.
And you nailed that on the head. When it comes to what robots are going to be replacing is those repetitive tasks, even like picking and stowing, or what the Kiva system did was it just replaced people walking. So instead of walking miles and miles to pick things, it just brings it to you, and it does it in a more efficient way. In your opinion, right now, I mean, the idea that AI, robotics, automation, they're coming for people's jobs. That's the big question that's been on people's minds, and especially people that have come to this channel. But what would you say will be replaced and what can't be replaced right now anytime soon? So in the next 2 to 3 years, when you talk about robotics, what is that going to look like from the human perspective?
And what the human will do is the human will supervise, will manage maybe 4 or 5 different machines and make sure that everything is being performed within specification, within the realm of safety for the parts that are being produced. Of course, it's something that there's a good deal of structure built into place today that they can launch from. So I think they can move very rapidly into those kind of spaces. Yeah, some of the other areas where you've seen a lot of automation in manufacturing and distribution centers. And so that's
on the ground, because once you see how robots really just take that repetitive task, they don't think outside the box. There's no ambiguity to their process. They do one thing and they do it really well. Do you think that they'll be able to, are you going to see that ambiguity within the next 2 to 3 years where robots think more? Because once you put an obstacle in front of them, as of today, they really don't know what to do with a lot of that new information, because the facilities right now are built for humans where we're trying to integrate robotics. Is there going to be, are you seeing that type of change too, where they can deal with ambiguity a little better?
Yes, going from a couple of different areas. One, ambiguity in terms of, spatial locations, out of spec, the tolerances of the components that are trying to assemble into a whole. Their ability to measure that is certainly beyond the human's ability to do it on an ongoing basis. So as they bring together, especially in a job shop environment, parts for an assembly operation. They're going to be able to take observations on that are beyond the human's ability to do so, and measure and make sure that they're to a spec that allows them to be successfully joined.
Recently in the news, there was a security company that actually made a change to Windows in their security kernel, and that actually caused, I think, an entire region of computers to basically go the blue screen of death. I was actually working at Amazon at the time, and I could not log on because of one single software issue. So are you doing any safety net checks? Are there going to be different levels of people monitoring this from a human perspective? Or
humans can imagine the unanticipated. That is the largest blind spot in AI systems. Their reasoning capability to extend what could possibly happen from the change into combinatorial effects of a process into the future is one that I certainly wouldn't want to rely on in terms of protecting my personal safety. So humans are going to be required in there because of that imagining the unforeseeable. We have a skill there that's unique, and I think that's going to be the last bastion against the AI hordes in the future is humans' ability to see the unforeseeable.
And I am an AI advocate, so I don't want to sound like the negative person here. But when it comes to the thought process of a human being, eventually it's going to get to a point where AI, when they do notice an error and make a suggestion to fix that error, the human is going to most likely say, okay, that makes sense, to the point where some of the smaller things may become automated just because we trust that AI so much. And that's one of my concerns about going into the future, is that once you have so many things being automated, so many robots taking the place of the critical thinking of human beings, what does that safety net really look like if our trust in them is so blind because they've been right 100 times, but the one time that they're wrong and we push the button and says, yeah, go ahead with that process, that's when all, excuse my French, hell breaks loose. Like, what do those safety nets look like if we're putting too much trust in the system as is?
Certainly that's a very human reaction. If it's 99 times in a row it's been correct, you tend to project that the 100th time will also be correct. And I think that is a real risk, especially in safety critical areas, that we're going to have the skeptical human involved in that loop. So that,
just to put that into perspective, one of the things that I did as a product manager is when I automated some of my workflows with AI, whenever I had to make certain decisions, there was always the risk factor. Is it low risk? Is it medium? Is it high risk?
Yeah.
So that's my thought process. So if I'm making a decision and I know it's low risk and it's bad on my part, but the AI has been right 99 times. And if I do this, the worst case scenario is my website goes offline for a minute. High risk, I want to be able to evaluate that and say I took steps to ensure that this was properly done. Is that kind of how your company, the strategic part of it, is that part of the planning process? Or what are some of the things that you're trying to implement from a safety net perspective to make sure we don't have these larger scale issues that happen later on?
We do process, which I alluded to earlier, which is to play the lawyer. The lawyer thinks of every bad thing that could happen and tries to develop a remedy for it. We have to think about all of the bad things that could happen. How do we detect the boundary conditions that would allow that bad thing to happen? How do we prevent those boundary conditions from occurring?
At least right now, and we say this a lot, at least right now, that's where if I were to give advice to somebody that wants to, look for the future and what jobs will look like, it's going to be being that strategic thinker, being the lawyer. I call it the editor in the room, is someone that can go in and say, hey, these processes don't make sense. What scares me most about robotics is that the problem that exists in the future, in which AI and robotics can't solve, that we've removed a lot of our critical thinking to begin with. And there might not be that human in the loop that has enough knowledge to be able to solve for that. Do you see those kind of issues coming in the future when it comes to the automation processes and robotics, is that we just won't have the knowledge to be able to fix new problems?
Interesting reasoning to go through there in terms of, the AI system creating problems that we can't envision the solution to.
Or there's a problem that presents itself, which AI's never faced because it's never been trained on it, doesn't know what to do, where you want the human to be involved, but that human, if it's my son, and I love him, I do, but I worry that he's going to be the one that's going to have to solve for that. And I don't think that's going to be a good outcome.
Yeah, maybe that is a discipline that will have to be taught, which is robotic or skepticism of robots.
Skepticism 101.
Yeah. When you've been in the industry more than a week, you will have seen a problem that you didn't anticipate. Maybe we should have anticipated. Maybe we actually put in the necessary physical guardrails to never allow a machine to get misaligned in that fashion again. Those type of experiences have to be, our best when they're personally experienced. But we're not going to be able to do that with the full range of it. So we're going to have some sort of methodologies about how to methodically go through the risk areas, put in place those guardrails that will prevent them occurring. And that's the human's going to play an ongoing critical role in that. That can't be AI.
But it's those kind of problems that you don't understand off the bat, and you definitely will need humans in the loop. And I think it's always going to be there because we're never going to reach AGI, or what they describe as what AGI should be, where they can think on their own. Do you think that that's ever coming from a robotics perspective where they are human-like and can predict these things? Or is that just a far-fetched reality?
I see that again as the last bastion of humans.
Okay,
that I don't see in the current development, where the imagining the unforeseeable and looking at alternative states and the interaction of different elements. In that sense, very skeptical of humanoid robots ever achieving AI achieving that. If you define that as AGI. I think AGI is in the unforeseeable future.
I agree. I think there's a lot of hype that's out there. And if you were to give advice today to those that are starting to come into the working field, what kind of advice would you give as far as what should they be studying in school, or should they even be going to school? What does the future of work look like for those that are afraid that robotics are going to come take over their positions?
Once an engineer, always an engineer. And I am an engineer. I would encourage people to continue on a STEM track, learn the basics of what automation elements today are built from, and that will give you an ability to understand what is currently feasible and project what will be feasible in the future, and be part of the team that develops and implements that.
And with your company, the strategic partners and Xform and all that, I didn't even get a chance to ask you about the company itself. What are some of the things that you are trying to do, planning to do, or things that people might not know about you?
Well, we're a mix of different talents. I tend to be the engineering tech person that leading in that area. Okay. But the other principals are ex-CEOs of large firms, that have driven large organizations. They've sat in the seats where our clients live, and so that they can they understand the language, they understand the pressures, they understand what needs to be mobilized to make them successful, and that's where STA is really focused. The tools that we talked about, the AI, the humanoid robotics, any form of automation that we bring to it, are brought in service to those business objectives. And keeping our clients successful is what keeps us successful. And we have a lot of fun while doing it. There's always great things to learn. One of the fun things about living in this world is I get to see a lot of different companies. Not just automotive manufacturing, not just apparel distribution, not just HVAC distribution networks. You get to see so much, and then I'm always shocked at how much what we learned in that automotive manufacturing plant, how much that applies to a distribution center that moves furnaces. And so I really feel rewarded every day to bring that kind of value to our clients.
It was a pleasure talking with you today. It's always fun to talk to someone who's actually working in the field, and with your level of experience, you've seen where it's been and where it's going. So that type of experience, I haven't found anybody for that yet. So thank you so much for joining today.
I appreciate it. Yeah. What I enjoyed, Steve. Take care.